Okay, so I've got a problem up here. Again, this is actually a review of something that we looked at way back when in section 1.4. Okay, I'm telling you that tangent of x is negative 2/3, that x is an angle between pi over 2 and pi, and I want you to find the other 5 trig functions. Okay. And we pretty much have 2 options for doing this. There's what I call the triangle method, and there's the identity method. And I'm going to do this problem both ways. One thing I want to caution you of, though, is a lot of times people want to say, ooh, tangent is sine over cosine, so sine x must be negative 2, and cosine of x must be 3. Now that's wrong. If you can see why, great. If not, pause the video and think about it for a minute. Okay, we're all back. Okay. This is wrong because sine and cosine can only take on values between -1 and +1. There's no angle whose sine is as big as -2 or whose cosine is as big as 3. So the ratio between sine and cosines, when I reduce that fraction, is going to reduce down to negative 2/3. But that's the simplified version of the fraction. I can't just assume that the top is sine and the bottom is cosine. Okay. I'm going to do this first using my favorite method. I like option 1, which is the triangle method. So I'm going to draw myself a picture. Okay. Now here, this basically tells me that x is in quadrant 2. Okay. So then I've got my reference angle alpha right there, and I can draw a right triangle. I can't draw a right triangle with x in it, but I can draw a right triangle with alpha in it. And what I know about alpha is that tangent of alpha is the absolute value of negative 2/3. So it's just 2/3. So I'm going to just use SOHCAHTOA. Opposite side is 2, adjacent side is 3. Then I can use Pythagoras to solve for the hypotenuse. 3 squared is 9, plus 2 squared is 4. That's going to give me 13. So the hypotenuse is the square root of 13. So now I can use this triangle for all of my trig functions. It's just basically going to be a 2-step process. For sine, I'm going to say, well, we're in quadrant 2, so in quadrant 2, sine is positive. And then I use SOHCAHTOA for the reference angle, and I say 2 over root 13, that's the absolute value that I would attach to that positive sign. Then I can rationalize by multiplying by 1 in the form of root 13 root 13ths, and so I get 2 root 13 over 13. Cosine of x, same 2-step process. Now I'm in quadrant 2, so I know that cosine is negative. The absolute value that I attach to that is cosine of the reference angle, so that's 3 over root 13. And again, I'll rationalize by multiplying by root 13 root 13ths. So I will get negative 3 root 13 over 13. Okay. Notice, if I take sine over cosine, it's going to be this number divided by this number. I will get negative 2/3. But sine wasn't 2 and cosine wasn't negative 3. Or sine wasn't negative 2 and cosine wasn't 3. You know, these are numbers that have that same ratio, but they're not just the numbers that show up in the simplified fraction. Okay, once I have these, the other 3 I can just get by taking the reciprocals. So cotangent of x is the reciprocal of tangent, so that's going to be negative 3/2. Don't forget, if you take the reciprocal of a negative, it's still negative. Okay. Secant of x, that's the reciprocal of cosine. Now, rather than taking the reciprocal of this version, I'm going to remember that it was originally this with the root 13 in the denominator. And if I flip it, that just becomes negative root 13 over 3. And then cosecant of x, same thing. That was my sine. If I flip it, I get root 13 over 2. Okay. All right. So that was using option 1, which is the triangle method. Okay. Option 2 is to use our identities. Now, identities are incredibly useful. I tend to think for a problem like this, my preference is the triangle method. Okay? But there are other problems where I think identities are the way to go. So I'm going to show you, and you can use either method. Does not matter to me as long as you know how to answer these questions. So option 2 would be to use identities. I've already cautioned you, don't misuse the identity that tangent is sine over cosine. Probably want to start with a Pythagorean identity. And I want the one that gives me a relationship between tangents and secants. Now if I don't remember that, I'll start with this one, sine squared plus cosine squared equals 1. Does not matter what order I add in. Either way, I get the same thing. Tangent has cosines in the denominator, so I'm going to divide through by cosine squared. So this is now tangent squared plus 1 equals secant squared. Now what I can do is I can plug in the tangent that I know, and I can then use that to try to solve for secant. So tangent squared would be negative 2/3 squared plus 1 has to equal secant squared. That's going to be 4/9 plus, I'm just going to write that 1 as 9/9 equals secant squared. 13/9 is equal to secant squared x. So now I can take the square root of both sides. So secant, the square root of secant squared x is going to be the square root of 13/9. Now here, that's just going to be the square root of 13 over the square root of 9 is 3. This, remember, isn't just secant, it's the absolute value of secant of x. So that's going to take me to secant of x is either plus or minus root 13 over 3. And that's where I need to use this information. I'm in quadrant 2. In quadrant 2, cosine is negative, so its reciprocal secant is also negative. So I use the quadrant to help me make that decision. So now I've got secant of x is negative root 13 over 3. From there, I'm going to go to cosine, because cosine then is just the reciprocal of that. So that would be negative 3 over root 13. Now I can rationalize by multiplying by 1 in the form of root 13 over root 13. So I get negative 3 root 13 over 13. Okay. So now I've got tangent, I've got secant, I've got cosine, I still need sine and cotangent and cosecant. Let's do cotangent because that's easy. Cotangent of x is just negative 3/2. Just take the reciprocal of that. But I still need to get to sine. I think I'm just going to use my Pythagorean identity there. So sine squared x plus cosine squared x equals 1. I know cosine. So sine squared x plus negative 3 root 13 over 13 squared is equal to 1. Now that's sine squared x plus. Now when I square this, I'm going to square all of this. So negative 3 squares to give me 9 times root 13 squares to give me 13. I'm feeling a little lazy, so the denominator squares to give me 13 times 13. I can cancel one of those 13s. And that's going to equal 1. Now I think I'm going to write that 1 as 13/13, because then I can say sine squared of x is equal to 13/13 minus 9/13, which would be 4/13. So sine squared of x is 4 over 13. Can take the square root of both sides. If I want to, I can jump right to sine of x is plus or minus the square root of 4/13. If you feel more comfortable writing out the absolute value and showing those steps, that's totally fine. If you feel comfortable going here, that's fine. Okay. All right. So that's going to be sine of x equals plus or minus square root of 4 is 2 over root 13. So I've got to do two things. I've got to figure out whether it's positive or negative and rationalize. We're in quadrant 2. Sine is positive. So I've got 2 over root 13. I'll multiply by 1 in the form of root 13 over root 13. And I get 2 root 13 over 13. So that's my sine of x. And of course, once I have that, I can get cosecant of x. What I'm going to do is I'm going to go back to this version and flip it so that I get root 13 over 2. Exactly the same answers we got the other way. It doesn't matter which method you use, but make sure you're comfortable with at least one of those methods. Okay? All right, that finishes up this section for us.